All right, my name is Randy Syring. I am Chief Executive Developer at Level 12. Chief Executive Developer means that I do a lot less coding than I want to. Hopefully that's going to change in the next couple months. We're hiring somebody to be more of the executive person, so, or Lord willing, we will be. So hopefully I'll get to do more coding and do more engineering, and that's the type of stuff I like to do. At Level 12, we do web and database development. We use solid engineering, which is part of what I'm going to talk about today. How do you engineer your tests so that they are productive? Proactive communication, which has to do with our customers and also internally. And then modern development practices, which is also what we're going to talk about. The fact that we're even talking about testing and wanting to do it well means that I hope that we're close to the modern side of things. To make our customers really, really happy, I kind of joke that most of our customers actually aren't really, really happy, but it's not because our software sucks. They're just unhappy about other things. So from my perspective, they're really, really happy. So why does that matter to you other than just being a plug for my company? We do modern development practices. We're trying to stay probably not on the cutting edge. Here's the thing about the cutting edge. When you're on the cutting edge, you're not sure if what's there is really good, proven or going to work well in the long run. So I try to stay about 75%, of cutting edge is over here and this is legacy. Like, if you're still programming Visual Basic, you probably need to come over this way. So probably about 75%. I want the stuff that has already been put through the ropes. It seems like it's going to stick around for a while so that I'm not learning something new again next year. While at the same time not being so crusty that I'm missing out on some of the better stuff. The fact that we're using this with our customers is important to you. This is not just my side projects. I don't have 7 years of testing experience, but I've got 2009-ish, so going on 5 or 6 years of testing experience. We've got about 4,000 tests, I think, on one of our biggest projects. And those have been iterated on over time. So what I'm talking about today, it does work and it is maintainable in the real world. That's why it matters to you. However, my real world and your real world may be different, so your mileage may vary. The methods and concepts that I'm going to talk about today have been refined over years, but on a relatively limited number of projects, all with a similar scope. We build kind of business applications, custom business applications, and in the web development world. So you may be building other things. That means that what I'm talking about here today, may not be so directly applicable to you. I also value developer productivity more than application performance. And what I mean by that is I care about usability, but none of the stuff that we're doing needs to be very high performant. My stuff is serving a couple hundred requests per minute probably, and that's about it. So if you have different requirements for your projects, you may need to tweak or even supplement some of the stuff that you're learning here. At the same time, I do hope that it's going to be worth your time to listen. So one of the things I said in the last slide was that I really emphasize developer productivity. And the reason for that is I really feel like there's a lot more software development work to be done than there are developers. And if we take developers and we say good developers, that drops dramatically. My estimate, based on the people that I've worked with, is probably that 50% of the developers that are out there are mediocre at best. You've got another 25 to 35% who are usually pretty good and are trying to get better and know how to get better. And then you've got this top 10 or 15% that are just elite that I'm not a part of them. These are like the Guidos of the world, right? They're just phenomenal. Now, I may be being a bit unfair there, but I don't think so, at least not in my experience. So that's been my experience out there working with different teams of developers. I like the people who are trying to get better. I have no faults with people who are trying to get better, but there just seems like there's a lot of mediocrity. There's a lot of people who don't want to make things better. And I think a lot of that comes from being unsure about breaking things, right? When a developer lacks confidence in what they're doing, when they're uncertain, it seems like things are slow to change. And so that's one of the reasons I like tests, is tests give me a lot of confidence as I move forward that I'm not breaking things outside of the realm of the stuff that I'm touching, and so I don't mind refining things and making it better. Speaking of productivity, anybody know the difference between productivity and efficiency? Okay, any other thoughts? Explain.
Productivity is what you get done. Efficiency is, has more to do with what you could have gotten done had you been doing what you were doing better or using more effective tools.
Okay, so productivity is what you're getting done, maybe the value of what you're getting done, and efficiency is kind of a gauge of how well you got there, maybe. Okay, I like that. So I defined efficiency roughly as accomplishment with minimal wasted time and effort. Does that seem reasonable? Productivity is generating or enhancing value. So here's the thing. Sometimes you can be really efficient at doing the wrong things, and you're not productive at all, right? You can check your email 5 times a minute really efficiently, right? You can even have it set up to do that yourself, right? Just have it check the email server every 5 minutes. Very efficient. Is checking your email every 5 minutes productive? Doesn't it numb your mind? I hate it. Just for what it's worth. I have all email notifications turned off. If I need to look at email, I go look at it, and I don't want it pinging me for whatever it's worth. So here's the deal. The most unproductive thing of all is to make more efficient what should not have been done at all. And so my question is, are you building a tank or a milk truck? A lot of times in my experience when I go in and I try to work with business customers, people have sat around at a desk or a conference table. They've figured out this project they want to build, and it looks like a tank. It's got a turret, right? It's got your cannon on the front. It's got tracks, not wheels, and it's really big. And nobody in the planning sessions really had any idea of what those features would cost them as far as software concerned. So they tried to make the tool solve all their problems. Anybody else experience this? Yeah, okay. So the reality is a lot of times the customer doesn't need a tank. All they need is a milk truck. And you don't really want to build them a tank. You want to build them a milk truck. And so you have to work that out. And my point there is if you end up building them a tank very efficiently, you will not have served them well because what they really needed was a milk truck. So we'll cover why productivity was important in a second. Who here is convinced that testing is important? Everybody? All right, makes sense. You're coming to a, usually I ask this question at a bigger conference where this is just one talk on testing. How many of you are doing regular automated testing, let's say, at least 50% of the time? Okay, so the rest of you, are you testing your code? Sometimes. So how many people write the code, never test it at all, I'm not talking about automated testing, just never test it at all and ship it and let the customer test? Anybody? Yeah, I mean, probably never, right? You're gonna try to test it, even if you don't have automated tests, you're gonna pull up the browser, you're gonna run the command line, you're gonna make sure that what you just is doing what you hoped it would do, right? Let me ask you something. Is that task, if you're not doing automated testing, is that task an investment or an expense? Why? Whoever said expense, tell me why.
You just spend it once and you keep spending it, whereas an investment you get nothing back and you have to do it over again.
That's right. So the answer is it's an expense because you've done testing that one time, but you can never use that time again. You've done it once, you've tested it, you've confirmed it, but you'll never be able to, every time you want to repeat that process, you're going to have to make another expenditure, right? If you write automated tests, the automated test that you write may take longer the first time, and may take you 2 or 3 times the amount of time that it did to do it manually, sometimes. But at the end of the day, is that an investment or an expense? It's an investment. Give me the reasons. For those who are not doing testing, tell me why. What are the big hang-ups that you find?
I have an end-of-life Java app written by a third-party consultant.
End-of-life Java app written by a third-party consultant. So how much time are you spending on that? Are you doing full-time on that?
Temporarily.
Temporarily. Okay.
Okay,
so he says, the main goal here, we know we're not going to maintain this code. We're just trying to basically make patches, I would guess, fix bugs. Any feature upgrades?
Well, we're upgrading our mail servers from almost 07 to 2013, so we have to expand. But I convinced them to do it the simple way rather than dealing with the mixed environments, which we can't do that.
Okay, I can understand that. That's not a bad reason, and we'll get to why I think that's true here in just a second. Anybody else? Reasons not doing testing? Not in the budget? Okay. Just curious, is testing in the budget?
At the end of the project, not through the project.
So you're writing all of your code, you never test it, you get all the way to the end, and then you start testing it.
Yeah.
Okay, now I'm not talking automated testing here.
No.
Okay, you're testing it as you go along, right?
There would be more testing if we could fit it into the budget, but it would never be approved by the partners.
So are you when you write your code, you just write it. You never know if it works.
That's what I've seen most of the time.
Okay. All right. I've never been in that situation, but okay. All right. Anybody else? Reasons for not doing testing? I mean, not in the budget is a common one, right? There's a perception that testing takes longer and is more expensive. And that can be true.
I think a lot of people don't test because
They don't test because they don't know how. How many people don't do things as software developers because they go, oh, it's going to take so long to learn, and then I'm probably not going to do it well, and that's just another thing. Anybody feel like that sometimes? I mean, if you're trying to be a good software developer, you're reading Slashdot, you're reading the Hacker News. If you're not careful, you're going to be overwhelmed to make any change because there's just so much that you could do, right? All right, so one answer I didn't hear is it's untestable, right? I don't know how to test it. I guess that maybe kind of goes with I'm not sure how to do it. So I took your answer as I don't know how to test, period. There's sometimes where maybe you know how to test, kind of, or even you know how to test well, but you've got some chunk of code or some app and you're like, this is just so, I don't even know where to start with this. So sometimes the code feels untestable. We're going to cover some of that in the second talk. Perceptions on TDD, perceptions on test-driven development. Raise your hand if you think TDD is a good thing. Okay? Raise your hand if you have problems with it or don't like it at all. Okay? I got one. I appreciate honesty. I like that. Authenticity is good. I'm gonna come back to the TDD thing a little bit. I'm gonna take a brief kind of segue here, or a brief what do you call it when you meander off? I don't know, whatever it is. You know what I'm getting at. So, yeah, sidebar. A little bit sidebar. Let's talk about what kind of tests we're talking about. Okay, we're talking about automated tests. Now, hey, I have mind power. This is phenomenal. Okay, so. Yeah, exactly. Exactly, see? Interference. Okay, so unit tests. We have automated unit tests. Unit tests are trying to cover as little code as possible in little chunks as possible to basically isolate what you're testing from everything else in your environment. Does that make sense? Anybody have a question about that? I like to organize my tests kind of along the type of code that I'm testing. So I usually break my tests up, my unit tests up into model tests, which are just unit tests of the model, form tests, which are unit tests of my form handling, view tests, which are unit tests of my web views, and whatever else I'm doing. If I have an app that's heavy CLI, then I'll have unit tests of my CLI commands. There's functional tests. Functional tests, in the way that I use that term, means that I'm actually going through the WSGI layer in Python, in the Python web world, and I am interacting with my app through HTTP and getting usually HTML or JSON in response. So I'm kind of going all the way in. I'm starting at the top, going all the way down, and coming all the way back out. Functional tests just make sure that all of your unit tests are kind of coming together the way that you thought they were. But I don't do, relatively speaking, I would say most of our testing is unit tests, and then we maybe have 25% of our tests which are functional tests, if that. Then you also have browser tests. So this is where Selenium comes in, where you're actually testing your JavaScript. We don't do a lot of this because our JavaScript has a tendency to be kind of one-off, and Selenium is just a little bit higher overhead for us than what we like to do. If you have a different type of app or you're in a different type of scenario, then it may be very important for you to do Selenium and JavaScript testing. There also might be some other type of testing you need to do that's infrastructure dependent. You may need to do performance testing. You may need to do integration testing where you actually have real data going all the way through from realistic transactions, and this just really kind of depends on the scale and scope of what you're doing. We don't do any of this. All of our tests are run in a local developer environment, and that's sufficient for our needs. So I put that really in the wrong place. That should have been next probably. But so here's my concerns. I know a lot of people said TDD is great. For me, TDD feels a little bit too militant or idealistic, however you want to do it. Sometimes I need to be more flexible. There's times, especially when I'm coming into a project and I need to start writing an API, that I don't want to get bogged down in testing it. And I know that's going to be somewhat heretical for a guy on testing, but the reality is I'm not sure that the TDD approach always results in optimal productivity. So from my perspective, the way that I want my developers to work and the way that my customers want me to work is they want to maximize productivity. And so sometimes, while I think TDD is has some strengths, I think the inflexibility of it can sometimes result in a lot less productivity than what you might otherwise get if you took a more balanced approach. This may not be fair to test-driven development, the best advocates of test-driven development, but this is my opinion of how it's presented in the wild. When you read Slashdot comments, when you read Hacker News, you talk about testing, you get this impression, at least I get this impression, that if you're not doing TDD, if you're not writing a test before you write any line of code, that you're just doing it wrong. And that's the kind of inflexibility and, what I said earlier, that slows us down as developers, uncertainty that makes me really unproductive. I'm like, oh, should I write the test for this, test first for this? It doesn't really seem to fit. I'm really not even sure what I want this API to look like yet. And so I think there's a better approach. What I describe, the term I like is test-centric development. And this emphasizes practicality and productivity. And what I mean by that is it takes into account that we have limited resources. We are finite beings. Our customers have limited financial resources. And we need to be balanced in what we test and what we don't test. It also takes into account the 80-20 principle, which states that a lot of times 80% of your value comes from 20% of your work. And I don't know if you've done this, but I've been in a situation where I've been testing code, and easily, I easily get to 80% test coverage in 20% of my time. And I spend maybe the first day getting there, and I spend the next 4 days filling in all the gaps. Now, sometimes that's going to be important, but you know what? Sometimes it's not. When done rightly, so it gives the developer the flexibility to say, along with management and expectations based on the development team, to say, you know what? I don't think a full testing of this particular feature is worth the time that it would take for me to test this. When done rightly, I think this methodology results in significant test coverage. This is not a get out of TDD jail card. If you don't like TDD, this is not going to help you at all, because there's really a lot of the TDD underpinnings I buy into. I just think we need a little bit more flexibility when the testing really does become cumbersome and the value of the testing is no longer so significant. Let me give you an example of this, which I referred to earlier. Our JavaScript in our apps has a tendency not to be very important. You know, we might have a form where we want the buttons to be dynamic and or the rows to be dynamic, and unfortunately, we're not using a form framework that does that for us, so we kind of got to write a little bit of JavaScript every time we want to do that. I don't want to fire up Selenium, and I really don't want to test all of that. I could, but we don't do a lot of Selenium tests. Every time we get into it, it's harder for us, and at the end of the day, the code that we're writing probably takes us an hour and a half to write. If it's broke, it'll be immediately broke, right? The stuff that we're doing, I mean, it's just not going to work. And of all the other things that we could spend our time on, this one page is probably not going to be touched by that many people. If it was an app, let's say it was something that was going to be used by 80% of our people, then I absolutely would go ahead and do the Selenium test to make sure that it was well tested. But a lot of times for what we're doing, it's just, you know, it's like 0.5% of the app, and it doesn't justify another 2 or 3 hours for us to get the Selenium test working. So from my perspective, how can you do test-centric development? What are the guiding principles? Confidence and quality increase with testing. I think that's pretty obvious. I think that's why we're all interested in testing. This is the same as TDD. I don't think you should have dedicated testers. Well, let me take that back. I think your developers should always be testers. They should always be testing the code that they're writing. I do think there's a place for dedicated testers. I used to not think this, and then I read an article by somebody who talked about why they thought this was important, and basically the gist of the article was, if you have dedicated testers, they will think about your application a different way than the developer who wrote it. and they will come up with things that will blow your mind about how to use it, and they will find bugs in a way that the developer, just because they have lots of assumptions they're making that the tester doesn't share, and so the tester ends up being able to find a lot of bugs that that the developer didn't. So, but I do think developers should write tests. And I do think we should write tests first when feasible. I absolutely think, especially on bugs, right? You get a bug, it comes in, we have exception reporting. If our production apps throw an exception, the first thing my devs are supposed to do is write a test to reproduce the bug. Once the test is there, we see the same bug, then go fix the bug. Does everybody understand that? Any questions about that? I think that's a really helpful paradigm. I absolutely think it's the best paradigm for fixing bugs. I just, once again, I think we need some flexibility when the task that we're doing at hand doesn't fit that model very well. So I talked a little bit about, so test-centric development allows you to cut corners a little bit when needed. And I think it's important to figure out where to cut corners. Core functionality should not be where you're testing corners. All of our model code, all of our database interaction code, all that stuff should be tested 100%. There's really no excuse for not having it tested. It's all unit tested. It's relatively easy to test. As you get to the edges of the application, those are the areas where I say, hey, if you got to make a call and you got to cut some stuff because of resource limitations, cut your stuff on the edges, but make sure the core code, the stuff that's used most and or is most important if it breaks, right? So your payment system. You probably want your payment system to be completely tested. Your Facebook feed, I guess it depends on Facebook, how important Facebook is to you. If you have the resources and they're available, test everything. This is really important. If any managers or stakeholders here, or just all developers, manager, stakeholder. So here's the thing. If you have a manager or a stakeholder who never asks you about tests, tests are not important to your organization, and you're fighting an uphill battle. You have got to get the management to see and understand, if possible, how important tests are. When the question starts coming from management, what kind of test coverage do we have? Did you test that? That's when you're really going to see developers start buying into testing. When the questions that come from management and stakeholders is always, is this ready yet? Is it done yet? How much money did you spend? Testing is going to be out the door, right? Because you can just, it's clear that it's not valuable to the organization. Okay, questions so far. I like interaction. So any questions about, you feel free to push back on the test-driven development stuff. Any questions about what test-centric development looks like in the real world? Anything?
Is there a point where you're spinning your wheels too much in the tests and where it may not be benefiting from that investment later?
So the question is there a point in the test, is there a point sometimes in testing where basically you're spinning your wheels too much and your investment is not really turning into an investment? It is a unit, it is a test, but the reality is that the benefit of the test compared to the time invested is small. Yes, absolutely. And that's where I would say take into consideration what your development team is, who your customer is, what your resources are, and ask the question, is that really needed? If you're in an organization that has a 100% test coverage policy and you got to get it covered and everybody's willing to spend the resources to do that on principle, that's great. Love it. Most of us don't exist in that world, at least I don't. And so I have to make trade-offs about where I'm going to have good coverage and where, because I'm getting good coverage over here, I maybe have to make exceptions elsewhere.
What are your thoughts on inherited code? So code that hasn't been tested and now you're in charge of it, or it's ongoing?
So the question is, what do you do about inherited code, stuff that comes in, you didn't code it in the beginning, there's no tests. I'm going to get to that question in a little bit. I'm going to cover that for you.
It seems like you're just doing TDD for the core of your application and then just being a little less strict on the perimeter. Is that accurate?
That's true. So he said, it seems like you're really doing TDD at the core of your application, but just being kind of less strict at the perimeter. I'd say that's pretty close. The only exception I'd maybe make is sometimes even when I'm building the core, because my mind doesn't. And I know the TestDD people are going to say, put your API in your tests, and then figure out how you want it to work, and then build it in. You know what? As a developer, for some reason, that just doesn't always work for me. I need to write my code first because I understand the customer's problem, and so I can write the code to solve that problem better than I can write the test sometimes. So I would say what you said is generally true, with also the exception that I don't want to feel as a developer like I'm doing it bad or wrong if I don't start with the test first. Anything else? Questions, comments?
So, like, the biggest problem I have whenever I don't write tests first is I end up writing tests that would have passed anyway because I'd mess up my tests. How do you deal with that if you write the code before the test?
Okay, so the question is, I find sometimes that because I've already written the code, basically I'm writing tests and I'm not actually sure that they're testing the application, right? I may have messed up the test. A lot of times I break it. So I break the code just in one small place. I see the test failing. I fix the code trivially, and the test passes, and I know that I've tested what I wanted to do. Yeah, so I do like test to fail first, and sometimes I do that artificially to make sure that paradigm is in place. Because I've had the same thing. You run your test and you realize, oh, the test passes and it's not even testing what I thought it does. Code coverage can help with that sometimes, not always, because you can get logical errors that are covered that have test coverage, but the logic isn't fully tested. Okay. So, just curious, TA number 1 means takeaway point number 1. I've got 5 of these. So summarize this however you want to. Basically, do TCD is my preference. If you're in an organization that will let you do TDD, great. Just don't be one of those militant guys on Slashdot, right? Or gals, like, just don't. Encourage people to test. Don't make it so hard for them that they don't want to get into it. Okay, so here, I'm addressing now a little bit, I don't know, what was your name? Patrick. I'm addressing here a little bit what Patrick said. So what happens, you get some code, it's a mess, maybe you wrote it, maybe somebody else wrote it. There's no or few tests, there's little buy-in in your organization, you believe in testing, but you're having a hard time justifying the resources to do it. Here's what I think you do. Number 1, start talking about the fact that everybody is testing anyway, and it's always an expense. It's never an investment because the tests always have to be repeated. Start talking that way. Start talking about investment versus expense. Start talking about asset versus expense, and you will perk the interest of some of the people in your organization. I think the biggest thing is just get started, right? So many things are much easier to get into than we think they are, and we're just overwhelmed by the prospect. And yet, when we start learning and we simply do it, we realize, you know what, that wasn't so hard at all. Ignore the boundaries. Ignore the hard stuff. If you're not sure how to test email, don't test email. If you're not sure how to test the web API to PyPy, don't test it. Pick something else. Start with unit tests where everything you need to test is right at the beginning. Get comfortable doing unit tests. A lot of your unit tests, you could probably get significantly high test coverage only doing unit tests. Now, some of you may end up having to refactor in order to make that happen, but a lot of times you can refactor stuff, and we're going to cover this, to move the hard stuff out to the edges so that you can still unit test your core. Already covered the middle point. Show others how to run your tests. If you've done tests, let's say you got 50 tests out there. Pull one of the developers, maybe at a developer meeting, say, hey, can I at least show you guys how to run these tests? It's really easy. You pull it up, you run the tests, and they see 50 passing tests, and somebody goes, wow, that's it? Yeah, it's all there. I only have 5% test coverage, but running tests is really easy. Takes 0.5 seconds. Wow, visuals go a long way. Set up continuous integration. Somebody's going to talk about continuous integration later. With coverage output so that you can show people. Managers need visuals. Stakeholders need visuals. Show them code coverage increases, even if it's 1% a week. Hey, we're making progress. It's getting better. Talk about why that's important. So the summary of all of that is, how do you eat an elephant? Basically, don't get bogged down by the chaos. Just start and then increase little by little. I liked this quote from jod.org, which has some software. They said, we have one simple rule, just increase coverage by 1%. We are constantly increasing code coverage by writing more test cases. Even if the increase is small, it's still a good thing to do. Make sense? Just get started. If you're overwhelmed by it, learn PyTest or nose test, do the quick start tutorial, pick one thing in your app that looks like it's going to be really easy to test, and write a unit test. And you'll do it, and you'll go, that's kind of fun. I like that. And if you don't, maybe you should be in a different business.
I'm also the that is from the
Okay.
at the test level and at the code level. So, and what's the experience of people in terms of how things are done in the organization, especially if you have, to me, I look at it like if you have a different testing arm or person, it's like separation of powers. To me, I would like that happening, like you said, they might look at things differently from the way the developers looking at it at that time. And how, from, from people's experience, are the requirements that drive that are they driving from the same requirement? And how are we sure that we are monitoring coverage on both sides as we go along?
Can you summarize your question for me?
It's just on both sides, test coverage, code coverage.
Test coverage.
How does it relate to the requirements that drive it?
Okay. So what I find is that most of the time my stakeholders and customers are not at all expressing requirements in terms of what I can, of really what the test is. That's my job as the project manager to communicate technical level requirements based on the business level requirements. It would be ideal if you could do behavior-driven development or behavior-driven testing, is that what something like that, you know, where they write out the test in terms of the business requirement. The problem I have with that is what I found is that testing is a lot more complicated. The code is a lot more complicated than the business requirements dictate. And so I think as developers, you have to be smart about identifying what you need to cover, what you need to test. Code coverage helps. You know, if you're writing the code and it's not covered, ask yourself, why is it not covered? Did I forget it? Is there a reason? In my opinion, your test coverage should always be 100%. Like if you have a test that is not being ran, either get rid of it or maybe you've duplicated the method name or something. Like test coverage should always be 100%. Code coverage, I think, is one of those things with the test-centric model. I think you have to define that at the business level. What, resource-wise, all things considered, what is a productive level of test coverage for this project, this customer, this stakeholder? And a lot of times, as you get better as testing, as your toolkit gets bigger and more developed, you'll be able to do more testing later on. All right, I need to go on, sorry. I hope that covered it. Sure. Testing needs to be a first-class activity. It's okay and even preferable to change your code to make it easier to test. I'm going to show an example of this. Don't be surprised when you start creating framework and utilities to help you test. Look, how many people write raw HTTP to the socket when they need to go out and get something off the web? Anybody? Why? Because it's dumb. We don't need to do that. There's requests, right? Use requests. In the same way, you're going to see patterns in your testing, and it's going to be dumb to repeat that pattern every single time. Make a library, make a helper, make it easy. Your tests are just code. Use the same principles that you would use in your other code. If it makes sense to refactor, refactor. If it makes sense to have helper libraries, have helper libraries. If you're using a lot of the same stuff in the organization and you have idioms that are common or maybe even required, great. Put it in a library so that everybody's not repeating it all the time. Teamwork matters. Tests are basically just more code. Use the same methods for team collaboration that you use now. Document how to run your test, preferably in the README. I love testing. I hate checking out a project and not knowing how to run the tests, right? Yeah, we got tests. Great. I see the folder. How do I run it? Do you use PyTest? Do you use Nose? Is there any database setup? What do I need to do? Put it in the README. Make it really easy. GitHub, Bitbucket, they all show the README in formatted text on the web. Usually I'm hitting the web anyway to get the project, so I can see right there in front of me on the web page what I need to do to get started. I love that. Your teammates are going to love it too. Organize your tests intuitively. I'm going to talk about that in just a second. Just like everything else in teamwork, agree on common paradigms. Discuss possible changes. When you think you have a practice that could be improved, talk about that with the team. If you're in an organization where it's better to ask forgiveness than permission, then do it and talk about it later. Just, you know, I mean, just because it's testing, it's not this weird thing that nobody's used to. It's just code. Manage it like you manage your other code. Here's something that really is going to help your team. Do everything in your power to limit cross-test contamination. What I mean by that is, if this test over here needs to be run before this test over here, that's really, really bad. If this test over here is deleting stuff out of the database that this test over here is expecting to be there, that's really, really bad. What's going to happen is you're going to have this guy, he always runs this test one way, this guy or gal is going to run it the other way, and then it doesn't work for them and they don't know why, and it's a big pain in the butt. Write your test remembering that other people are going to run them. The other thing is, which I didn't put here, is specify your dependencies. In my repo, or maybe in the level 12 repo, which you can find on Bitbucket, there's a project called PyDeps, P-Y-D-E-P-S. It talks about how we manage our dependencies. One of the issues we've had in the past is a developer would be relying on certain versions, and in our requirements files, we were not specifying versions all the time of everything because it's just a lot of stuff. We would just specify the high level, what we needed, and then expect pip to bring everything in. Well, what we found is over time, those libraries would rot, and somebody else had updated, it was working for them, I'd pull the code, it would not. And so basically, we have the terminology of snap files, they're just pip freeze output, but we call them snapshot files of environment, and those need to be committed and updated with everything else. So you have the high level files that specify your requirements from a developer perspective, but then you also have snapshots that specify what is a known working environment, every single package that's needed, and we found that to be very helpful since we've started doing it. This is how I organize our files. In our app, we have a tendency to break things up kind of like this. We usually have an application module which sets up the app. We do a lot of Flask applications, actually WorkZug applications, because we use a custom framework, but it's similar to Flask. We have a lot of form logic because we do a lot of form posts, so our forms get split off separately. Our model is usually split off separately as well, all of our database logic, and then we have our views, which are specifically for the web. This is a contrived example. They don't actually look like this, but I think you get the idea. I'm breaking out my code, right? I mean, everybody does this. You may not do it like this, but you're trying to group things in a way that makes sense. Do the same thing with your tests. When you come in and you look at a folder structure like this, do you have any idea where the test for them, or do you have any question, is there any hesitancy on your part where you're going to find the test for the model? It's not, just make it simple, make it intuitive. If people on your team are complaining about not knowing where to find stuff, fix it, move it around. I mean, they're tests, right? Move your tests, run them, make sure they run. If they ran, I mean, you're doing good. Put tests as close as possible to the code it tests. So one of the other things we have is we have what we call components, and these are basically kind of like Django apps where you have this subset of functionality which is really tied to itself. Maybe it's, trying to think of a good example. So maybe you have a users component and you use this all over the place. So if you have components, put your test for your component with your component, right? So I know if I'm in a component, I want to know where the tests are going to be right in there. I'm going to skip some of this stuff. You can look at the slides if you want to. Make testing easy, 3-step rule. I should be able to check out the code, look at the README, figure out what dependencies I need to do to set it up, maybe change a config file, set up a DB, and then I should be able to run my tests and have them all pass. It should always work that way. If your environment is really more complicated than that, I guess you can adjust that. But this is what we try to do. That way, developers never have a concern about how do I get into this project. They go out, they check out the code, they look at the README, they do the setup, and they run the tests. And if everything's passing, they can jump into whatever problem they had, and they are highly confident that the changes they make when they push them back are going to be in line with everything everybody else is doing. No broken tests. If you break a test and you commit a test, you should get slapped on the knuckles with a ruler. Don't commit broken tests. Continuous integration helps with this. When you start having emails go off that says so-and-so broke this test, and it gets emailed to all the developers every time that happens, or better yet, you have somehow a red light in the office that starts blinking when build is breaking. This is phenomenal. You will be amazed at how motivating that is for people to make sure that they run tests before they commit code. If you just have to do it, once again, we're talking test-centric development. If for some reason a test is breaking, you know it's not a big deal, or you know it's not even going to be true in production for some reason, but fixing that test is going to be a problem, skip the test, put a comment in there about why the skip is test, and create an issue to fix it later. Your testing should be as fast as possible, quick iteration. I can't tell you the story because I'm running out of time. We talked a little bit about being able to kind of dive into specific tests. The way that I like to do tests as I'm working on a feature is I actually like to run one test or just a class worth of tests at a time. That way the tests are happening really fast. I'm only focusing on the code that's working. And then as I get closer to that kind of being done with the coding part, then I start backing out and maybe I run the whole module, and then I maybe run the whole component, and then I run the whole app to make sure I didn't happen to break anything anywhere else. So that way I'm not running all the tests all the time or all the component tests all the time, because the longer it takes to run your tests, the less often you're doing it, and I want to run my tests really quick. I want them to be under a second every time. Bam, test complete, bam, test complete, bam, test complete. We're going to talk about PyPyCalc. I'll get into it a little bit later, but the short version is that PyPy has a JSON URL that will give you information about packages. This is kind of the structure of the JSON. You've got info about the package. This is a snippet of some of the stuff that's out there for pip. It gives you a URLs key that has a couple items in there that give you both downloads and size. Well, if you know the number of downloads and you know the size, what can you calculate? Bandwidth, right? You use bandwidth used. And so that's the whole point of PyPyCalc, is to calculate the bandwidth used by the current release of a project. So you know what, I'm going to have to, I'll finish this up next, because in my next talk we basically go into PyPyCalc and how to use it. So any questions, comments, feedback right now?